We're going to work again on the customer class and add a few more features and make it a little bit more complicated, but the whole goal of this exercise is to be able to understand better what the keyword this means. All right, so suppose that for every customer that we have, we also want to keep information on the dependents that that customer has. How can we do that? We could keep, for example, an array where we keep inside that array the names of all the dependents. So we would have to create a string array and say, let's call it dependents. And what should we do next? We could, for example, create a new array and give it an arbitrary size that we think is big enough. Maybe keep track of up to 10 people, up to 10 dependents. Now, if we do it like this, what would it imply? It would imply that every customer object we create would have, by default, a string array of dependents of size 10. It might be better, from a modeling perspective, to have a parameter in the constructor that will be the size of that dependence array. And instead of doing that, I'm going to be lazy here and type as less as possible. We're going to just make the declaration at the top, and then inside the constructor, we're going to initialize the dependence array. We're going to create the dependence array, not initialize it. We're not going to put any values in it, but we're going to create the array, and it will be an array that has length size, the size that is determined. So every new customer will have a different size for the dependence array. Now, notice that this time in line 8, I did not use this dot dependence. It is perfectly fine to do so, it is correct to do so, it is not necessary to do so. It is absolutely necessary on line 7 because we have two variables called name, and there is no other way to access the field name other than use the this.name. Every time we just write name inside the constructor, it will be referring to the parameter. Great. So now we also should modify the constructor call and say that Alice has two dependents maybe and Bob doesn't have any, an arbitrary number again. Now assume that we also want to have a way, it would make sense, for adding dependents to a particular customer. How can we do that? Perhaps we want to have a method that, for the moment, I will not have it return anything, that will be adding a particular dependent to a particular customer. We will see what we need as a parameter. So, for example, say that Bob is a dependent of Alice. Then perhaps we want to provide the name, Bob's name, and insert that name to the dependents array. Right? So we would have to say dependents of some index becomes equal to n. So we insert the name of this particular person to the dependents array. Now what should the index be here? Well, we should probably be keeping track of how many dependents we have already added to this particular string array. So maybe we will have a variable called current dependent, and we could initialize that variable right here. If we don't, it is initialized by default, but when we have a constructor, it is a better practice to initialize all of the fields at the same place. So even if we just initialize it to 0, it will be better to do it inside the constructor. So we initialize the current dependent to 0 so that when we call the has dependent for the very first time, when we want to insert a dependent at the very first time, then that will be inserted at index position 0, which is the right thing to do. Then we should also increase the value of current dependent by 1, so that next time has dependent is called, we insert the next dependent at the following position. We could also do all the same thing in this line by having the plus plus after the name of the variable. Notice that it would not be the same if we had plus plus current dependent, because with this way, remember, it will first increase the value of current dependent and then store n to the new index. What we want to do is, in the way that we have written the program, is store at the current index, and after the store has happened, increase the value of current dependent. Great. So now let's go and use the has dependent. How are we going to do this? We're just going to say, remember we want to say that Bob is a dependent of Alice. So we will call has dependent through Alice because we want Bob to be stored in the array of the Alice object. And we will provide Bob's name as a parameter, like this. Now, a different way to do that, a different way to model our problem would be by, instead of providing a string there, to actually provide a customer object as a parameter. Why would we do that? Maybe inside has dependent, we wanted to do more bookkeeping about that particular customer that is a dependent of another one. Maybe we wanted to keep more information about that particular customer. What kind of purchases have been done by that customer? How do they relate to our current, to this customer, and so forth. That would also mean that the customer class would have more fields. So we will make the customer class more complicated, and this is beyond our current goal. However, what I want to say is that there could be good reasons to change the field here to have it as a customer. And so we will also have to say name n.name, so that we store the name of that particular customer, and we will need to change the call also to has dependent, so that we provide a customer object. I have stepped through the visualization of the execution to the interesting point for us, right before line 21 of the code is executed, which is the new part, right? We have already seen what happens when we invoke the constructor, which is what is on line 19 and 20. And on the right, we see the result of how the state of the program is after the execution of line 20. So we have two customer instances that are referenced by two customer variables, Alice and Bob. Each of those instances has a particular name, Alice and Bob. The array for dependence of the Alice object, since we provided argument 2 as the constructor, has two positions, so it is an array of size 2. We have not given any values yet. Since it is a string array, all of the elements will be initialized by default to null. And then current dependent for both objects is 0. The dependence array for Bob doesn't have any length because we provided 0 as an argument in the constructor. So this is a picture that we should expect. Now the interesting thing, and what will help us in understanding better the use of this, is what happens when we are calling alice.hasDependentBob. Remember that both Alice and Bob are customer references. So let's move forward and see what happens. As soon as we call hasDependent, as soon as the execution of an instance method is starting, we need to think what is the value of this. Remember that here we don't explicitly use this, but it could definitely be this.dependence. Every time we use this dot something, it is referring to the instance something of the class. So what is the value of this? It is the value of the current object. What is the current object? It is the object through which we are calling this particular method. we are calling hasDependent through Alice. So the current object is the object that Alice references. So the same object that the Alice reference is pointing to. Great. So what do we do inside the hasDependent method? Well, we need to assign to the dependence array at the position current dependent this particular name, n.name. What is n? N is the parameter of the hasDependent method, and its value is the Bob object. Why? Because it is Bob that we passed when we called hasDependent. So Bob is referencing this particular customer instance, n is referencing exactly the same customer instance. Let's move forward with the execution and see what happens. What do you expect to happen? The answer to that question is that two things we see happen. One is dependence of 0 of the Alice object now has the same value as n.name. The second thing is that the current dependent value of the Alice object has increased by 1. The rest that happens is not that interesting in the following steps. The hasDependent method returns, and we see the picture at the very end of the execution.